For centuries, the study of literature has relied on close reading. A scholar isolates a specific passage, analyzes the symbolism, and extracts the underlying themes. But that approach hits a hard limit. It relies on subjective assumptions, and the human brain cannot process thousands of pages simultaneously to spot the patterns hidden across massive collections of text. Digital Humanities addresses this scale problem through a methodology known as distant reading. Methodical distant reading reconfigures literary works into structured, computational datasets. Analyzing literature as data does not replace the human scholar or strip away the meaning of a novel. Instead, these digital tools provide a rigorous empirical foundation. They allow us to test cultural theories against a broader statistical reality. We will test this methodology by examining generative AI, corpus linguistics, and text mining. By applying algorithms to prose, we can expose the structural, political, and cultural architecture engineered into our most famous stories. The first test of computational literature begins with AI language models capable of generating poetry. This diagram illustrates the mechanism behind the text. The AI maps statistical probabilities of word vectors by analyzing vast existing literary corpora. Because it calculates these probabilities so precisely, the machine successfully imitates human syntax, rhythm, and structural imagery. If an algorithm can mathematically replicate a sonnet, has it achieved true creativity? The boundary of algorithmic capability becomes clear upon closer inspection: semantic discontinuity. The logic eventually breaks down because there is no underlying emotional consistency. Human poetry is driven by lived experience, historical consciousness, and cultural memory. An AI calculates the statistically probable next word. A human author transforms personal experience into something unexpected. Digital Humanities positions AI as a collaborative tool that expands our understanding of originality. Corpus stylistics is a methodology that scans thousands of pages simultaneously to expose recurring linguistic patterns that are invisible to the human eye. To see how this works, we use the catalog of Charles Dickens as our dataset. This data array visualizes a query inside the CLiC software platform. Searching for the keyword fire across all of Dickens' novels yields over 1,700 results. That volume of data is too broad for a human to analyze manually. We need a computational filter. We apply the KWIC grouper tool, keyword and context. We tighten the parameters by setting a search span from L5 to L1, meaning the algorithm will only look at the 5 words immediately to the left of the word fire. Next, we inject a secondary filter word into that 5-word span, the word back. The chaotic results instantly snap into a specific, repeated narrative pattern. This data reveals how Dickens consistently employed bodily positioning to reinforce the gendered power dynamics of his era. We turn to George Orwell's 1984 for our final test of structural analysis. We ingest the raw text into Voyant Tools, a platform that renders prose into interactive quantitative visualizations. This word cloud is our initial frequency model, identifying the dominant vocabulary of the manuscript. The most prominent nodes quickly emerge: Winston, party, thought, and Big Brother. This network map shows how those terms relate to one another by visualizing their topological connections. The graph proved structurally how Orwell tightly interconnects concepts like surveillance, authority, and resistance. They are bound together in the data. This line graph takes those relationships and plots them across the narrative timeline to show how they evolve. Tracking word frequency across the x-axis exposes the specific structural moments where concepts of rebellion fluctuate against concepts of truth. When reading the book, you feel the tension building. These visual representations provide empirical weight to that feeling. Text mining displays the exact psychological and political claustrophobia Orwell engineered into the text data structure. We've examined probability vectors in AI, frequency analysis in corpus linguistics, and network topology in text mining. The primary revelation across these methodologies is that literary description is never neutral. It is built on quantifiable patterns that encode cultural meaning. The limitation of digital humanities is that algorithms cannot perform meaningful interpretation. Computational tools can build the map and reveal the hidden structures, but the human scholar must navigate the territory to extract the meaning. Choosing between close reading and digital analysis is a false dichotomy. Distant reading provides verifiable data points, while close reading provides the human context. This approach protects qualitative theory from subjective bias by grounding it in data. Modern scholarship is increasingly defined by this integration of human imagination and computational intelligence. To understand a story today, we can no longer just read the words. We must analyze the data beneath them.